Let's talk about verification validation, which you can think of as a formal process for checking results. And in my series of videos discussing what's under the black box, I indicated that these terms, verification, validation, have different meanings. If I go back to the slide from that discussion, okay, verification is whether whatever mathematical model, I input into the code, if I solve it right. Whereas validation is looking at, is that mathematical model capturing reality accurately enough, for which we need experimental data, which we don't have here. So I won't do validation here, and I'll do verification. And for the Truss, the first thing to start off is sanity checks. This is for actually any problem. So as we were going along, we checked the deformed shape, whether that makes sense with where the truss is being pulled and where it's being held. And we also looked at whether whether it makes sense that a particular bar is in compression or tension. So we did that. Then we need to check if the solution agrees with the mathematical model. Okay, so did we put in the right mathematical model into ANSYS? One of the most important things in mathematical model is the boundary conditions, and in this case, particularly the boundary conditions on displacement. And we looked at the deformed shape and said, hey, we put that right. Are the displacements in the right ballpark? And this gives you a sense of whether you put in the right material properties, because if you put in the wrong material properties, usually the displacements are not in the right ballpark. So we check that. Was hand calculations. Is equilibrium satisfied? Now, this is a check that you can do for any static structural problem. It's very important because once you get the reactions, you can check whether they balance the applied load. And I kind of indicated that for one reaction, and one could do it for the others too, and that's important. So we did that. Okay, so it looks like we put in the right mathematical model into the tool. Now, did the tool solve that right? And usually it's solving the approximately. In this case, mathematical model is simple enough that the numerical error is negligible. And the way you usually check that is, one of the basic checks is to refine the mesh and see how your results change. We will do that, and then I'll discuss the results of that. And the other, series of checks one can do is versus hand calculations, right? Because in pre-analysis, one does the hand calculations. So we can check against, we can check the reactions, the axial forces, and the stresses, and we did all that. And in this case, we can, actually the hand calculations are exact for the mathematical model. Okay, so we've done a series of checks, and one thing left to do is to see what's the effect of refining the mesh. Let's do that next.